All right, so on this one, we want to find the length of x, and let me give you some information on this one, okay? I happen to know, or it's in the reading down below, it says that a summer camp counselor wants to find the length of x in feet across the lake as represented in this little sketch. It says that the lengths represented from A to B is 1,800. So from A to B is 1,800. So I'm just going to jot this down. Now, those of you that I taught geometry, remember this? The line segment AB equals 1,800 feet. You guys remember that?
Yeah.
All right. And then it tells us that from E to B, it's 1,400 feet. So from here to here, it's 1,400 feet. E, the line segment EB, the length of that is 1,400 feet. And then it tells us from B to D, B to D is only 700 feet. So let's label that BD as 700 feet. And then CD is 800 feet. Oh, I need another color. I'll just use this. 800. So from C to D. And what they really want us to find is the length of AE, isn't it? So we don't know what A to E is. All right, so now to do this problem, we got to say this is a similarity thing, right? We know that when you have the bow tie triangles that they're proportional because we know that they're similar triangles, all right? How do I know that? Well, does anybody remember from your amazing geometry teacher last year what these are called? What do we call those? These two angles, this pair of angles, what's the special name for that? And what do we know about them? Vertical angles. And what do we know about vertical angles? They are always congruent. That's a perfect example of, remember I said to you guys in class, you got to go over something 27 times to commit it to your long-term memory. You remembered it last year, but you had to think this year. That's why it's so important to write everything down. Anyways, we know they're congruent. So if these two are congruent and these angles are congruent, what do I know about the third pair of angles? They're congruent as well. So because I know that they are all congruent, these are similar triangles. So I just have to set up a proportion and solve. Well, I know I'm going to need AE because that's what I want to solve. So I'm going to compare AE. What is AE compared to? Well, E has one arc. E has one arc. A has three. So that compares to DC, doesn't it? One arc, three arcs. Now I just got to figure out if I use 1,400, will that help? I don't know. I got to figure out what corresponds to DB, right? So, or BD. Well, BD has one arc and two arcs. So then I need, that corresponds to EB, doesn't it? So that proportion can be solved by cross multiplying. So I still don't know what AE is, but I do know that DC is 800. I do know that BD is 700. And I do know that EB is 1,400. Now you could cross multiply this, but what am I doing to 700 to get to 1,400? Yeah, it's a scale factor of 2. I'm multiplying by 2. If you had to guess, what do you think AE is? 1,600, but let's double check. The easiest way to solve this thing is to cross multiply. So I'm going to say 800 times 1,400 And then this, or another term that is called is bat and ball method, divided by 700 should equal AE. So I'm just going to plug this in the calculator. So I'm going to say 800 times 1400 divided by 700. 1600. That's what I thought. All because I read my book in school. So I know it's asking for x, right? But the value of x is equal to AE, which is equal to 1600. If we do a common sense check, that looks about right? That looks like it's 1600, although you can't always go by that.